Welcome to Interpret Scatterplots. This is lesson 1. In this lesson, we are going to look at an overview of scatterplots. We're going to look at how we can use scatterplots to model trends. We're also going to be looking at the data and interpreting it to determine if there's a causal relationship or just merely a correlation, meaning there's a relationship. We said scatterplots model trends. Here's an example or two examples of how they can model trends. We can have a whole bunch of data, but it's hard to see what's going on with the data until we graph it as a scatterplot. In this first chart here, first example, the title says Bump in Beauty Salon Business. And you can see what that means, that initially the beauty salon business went down, the net profit margin, the sales percent change are going down, but then at some point here, in this case 2008 and 2009, they're suddenly going back up. There's a bump in business. In the second chart here, we have pharma sales rep jobs take a tumble. And it's pretty easy to see what's going on from the scatter plot that in fact the number of reps has been going down, decreasing rapidly over time all the way here to 2013 where we only have 60,000 compared to back in 2006 when we had 105,000. So creating a visual image of our data, in other words a scatter plot, can really help us to start to interpret what we have. So how do scatterplots display trends? Well, first we should know that any set of numbers is called a set of data. So if we have a set of numbers, we call that data. A single set of numbers is called univariate data. For example, in this case, we have a list of monthly sales figures. Well, in this case, this is annual. But either a monthly or annual list of sales figures is just a single set of data. In 2007, we sold this much. In 2008, or by month. That is univariate data. We can compare that to bivariate data, which is what we will use for our scatter plots. And this is data that lists pairs of numbers and shows a relationship between the paired number, between the two paired numbers. So we have a couple examples here. We have grip strength compared to arm strength and sales compared to number of employees. So this one on the right, we have grip strength here on the x-axis and we have arm strength. And we are merely creating this scatter plot to see if there's any kind of relationship between the two. For example, the more grip strength you have, perhaps the more arm strength you have. And what do you think the scatter plot shows? That's our goal, to be able to interpret, is there a relationship? Also to determine if we have greater grip strength, does that automatically cause arm strength? With those types of things, you have to really think about it. In this first example here, we have the number of employees compared to the sales figures. So the more employees we have, are we going to have more sales? Do we see a relationship here? In other words, is there any kind of trend developing? So the key part of this slide is to know that scatter plots are graphs that show bivariate data, meaning we have a paired data set that we are comparing. Let's go back to trends in scatter plots. As we've said, a trend may show a correlation between two variables. Really all that means is that there's a relationship. We see a trend. In this case, a positive correlation exists if the value of one variable increases when the value of the other increases, which is what is going on here. We can see a trend. These dots don't form a perfect line. That would be a perfect correlation. But they are forming a trend, and I can predict where this is going. It's continuing to go up. A negative correlation, on the other hand, exists if the value of one variable decreases while the value of the other variable increases. So notice that on our x-axis, as we get bigger, our y-axis values get smaller. And you can think of this just like a linear function. This would have a negative slope if we were to plot a line through here. So this is showing a negative correlation, but it doesn't tell us necessarily whether it's a strong correlation or a weak correlation, whether it's negative or positive. It merely shows us that this is negative, and we have to look to the closeness of the dots to determine whether we have a strong correlation. In this example here, we do have a pretty strong correlation because these dots are fairly close together, forming a closer to a line than our positive correlation did previously. Also, as we said, a trend may show a causal relationship. which means one variable caused a change in the other variable. This is not always the case. Sometimes we just see a trend, there's a correlation, but it doesn't always mean that we have causation. Now let's look at this. Does this scatter plot show a positive trend, a negative trend, or does it show no trend? If you look at this, you could not predict what would happen here at 110. So if I were to continue out on the x-axis, 110, where would my next dot be? I can't tell if it would go up or if it would go down. I have no idea. There is no pattern here. There's no relationship. So there's no correlation, meaning we have no trend. So this is an example of no correlation. Now let's look at an actual example. In this example, Rachel runs a concession stand at the park where she sells water bottles. She keeps a list of each day's high temperatures and the number of water bottles that she sells. So here's our list. On the X variable here, we have the temperature, and on the Y variable here, we have the number of water bottles sold. If I just look at these numbers, I can't decide, is there any kind of relationship? The hotter the temperature, do we have more water bottles being sold? That's what I would predict. But by looking at these numbers like this, I have no idea. It's very hard to determine if there is a trend, if there's a relationship. So she wants to investigate. Let's create a scatter plot. Here is our scatter plot. So now you get a better idea of saying, hey, as the temperature gets hotter, we sell more water bottles. So we can plan and predict and stock based on the temperature. If we know it's going to be 110, we better have more water bottles in stock because we have potential to sell more. So notice in each ordered pair, the first number is the high temperature for the day, and the second number is the number of water bottles sold, as we stated earlier. Okay, all we did is plot each of these dots, and by doing that, we are able to see a positive correlation. And I would say there is definitely a correlation. Okay, in this case, we can interpret the trend. As the temperature rises, the water bottle sales generally increase. So there is a correlation between the data. Because the Y values increase when the X values increase, the correlation is positive. Additionally, the rise in temperature caused the increase in the number of bottles sold. So because of the temperature increase, that's causing more water bottles to be sold. Let's make a prediction now. A local coffee shop sells hot chocolate. The manager keeps track of the temperature for the entire year and the hot chocolate sales. He makes a scatter plot and he graphs the temperature on the horizontal or x-axis and the hot chocolate sales on the vertical or y-axis, just like we did with water bottles. Do you think the scatter plot will show a positive or a negative correlation? Is there causation? Explain. So without actually graphing, this is just a prediction. Well, what do you think? So when the temperature is low, we probably sell more hot chocolate. As the temperature increases, we probably sell less hot chocolate. So can you visualize what that scatter plot may look like? It probably will be a negative correlation, but I would assume, just like the water bottle sales, that there probably is a relationship. And then I might also say that the cold weather caused customers to buy more hot chocolate to stay warm. All right, let's look at some examples of correlation versus causation, because that can be very confusing. So is this correlation or is this causation? We have global average temperature versus number of pirates. Okay, here's our global average temperature here on the left. As the temperature increases, the number of pirates increase as well. We see that there is a correlation, there's a relationship there, but what do you think? Is it causation? And I would have to say no. The weather doesn't cause there to be more pirates. There is a relationship there. As it gets warmer, more pirates go out. But you could definitely say that the average temperature, the increase in the average temperature, doesn't cause the number of pirates to increase. There's just a relationship or a trend. How about this one? Your income on the y-axis here, as it goes up, you can see that it's related to years of experience. So as your years of experience in a job increases, your income also goes up. So is that a correlation? I would say yes, we can see a correlation because we can see a trend. If we can draw a line to mark that trend, we have a correlation. So we definitely have a correlation, but do we have causation? The more years of experience you have doesn't automatically cause your income to go up. That's not causing your income to go up. There's probably other things that are causing your income to go up, like promotions within your job or becoming specialized. So it's probably not causation, but definitely there is a correlation. Okay, here's our final example. Is this correlation or is it causation? Pause the tape and see if you can figure this out. All right, well, if we look at this, we definitely have correlation. And you can see that I could draw almost a perfectly straight line through these blue dots. And if I can do that, I have a correlation. In fact, I have a negative correlation. So what are we looking at? The more miles we travel, the less gas we have in the tank. In this case, I would say this is causation, because the more miles we drive, we use up gasoline. So miles cause the gasoline in the tank to go down. So not only is this a very nice negative correlation, we also have causation here as well. There's been many studies over the years, especially in medical, the medical field, where they've had a hard time proving whether lung cancer has been caused by smoking, and they had to do many studies in order to find that out, and they've done many scatter plots with that as well. So it can be difficult to determine whether there's causation. It's pretty simple to determine whether there's correlation. All we have to do is look to see if there's a trend. But causation requires us to think a little bit more. And this concludes our lesson today on scatter plots.